So on this page, they say the rod is rotated about NC so that the stone moves in a vertical circle of radius 85 cm. The angular speed omega of the rod and stone is gradually increased from 0 until the glue snaps. The glue fixing the stone snaps when the tension in it is 18 Newton. For the position of the stone at which the glue snaps, on the dotted circle of figure 1.1, mark with the letter S the position of the stone. Okay, so let us mark the position again. So what to do is, let's say I just quickly draw the figure again. So the figure is like this. Then they put here C, then I put a rod here. Then I put a rod here, then I put a stone there. So they want you to mark the positions of S. Position of S is where the stone will I mean the stone at which the glue snaps. So where? So it's either at the bottom or on top. Okay, so of course it is at the bottom. Okay, so you have to mark S at the bottom here. Okay, you have to mark S over here. So now, why at the bottom? So if you are wondering, so I can give a short explanation. So a short explanation here is, at this point, centripetal force is tension plus mg. And at this point, centripetal force is T minus mg. Okay, so because of that, there is a difference between the top position and the bottom position. The difference is like this. So tension is centripetal force minus mg if I rearrange the equation on top. And tension is centripetal force plus mg. Okay, so you see the information here. The glue fixing the stone snaps when the tension in it is 80 Newton. So the lower position can reach 80 Newton faster than the top position because this one is minus, Minus will make the tension smaller. Yeah, so this one is plus. Plus will make the tension greater, So because of that, as you can see, let's say I write one more equation. Centripetal force is mr omega square plus mg. So when the omega increase, imagine that when the omega increase, then everything on the right will be greater and they will reach 18 newtons first. Okay, it will reach 18 Newton first. The lower position will reach 18 Newton first and hence snaps. Okay, so that's why we mark the bottom as S. Now part 2, calculate the angular speed omega of the stone. So calculate omega. Okay. Calculate omega at which point? Is at the point when the stone at which the glue snaps. That means at the lower position. So we have to count the omega at the lower position, not the top position or not any other position, but at the lower position. So at the lower position, you want to find omega, so you have to use this equation, Okay, so now let us just continue from the equation that we have here. Okay, so it is where the lower position is where the glue and the stone snaps. So at that point, the tension is 18. Substitute value. And then the mass the mass is, okay, let's see first. Okay, they give us stone of weight 3 Newton. Okay, so the mg is hence 3 Newton is given. And then mr omega square, right? So W equal to mg, right? So if the W is 3, then the mass can be found out by using division 3 over 9.81. That's the mass. So we put this working over here to replace the m. 3 over 9.81. The radius is 0.85 meter. The omega is unknown. Okay. So we can find out omega. Okay, so let's count. 10 minus 3. Okay, so we will get omega as 7.60 radian per second. Okay, so that is the value for omega. Okay, so settle 4 marks.